Okay, good to go. Start now.
Well,
Okay.
okay, everyone. Thanks for coming. So today we're lucky to have a guest lecture. So Pascal Sun is one of our PhD students who's been working in natural language processing and various aspects of AI now for getting close to 2 or 3 years.
Yes, 3 years.
Yep. But he's very generous with his time, and he's kind of recognized that there's a lot of stuff that he had to pick up on his own coming through the PhD program. And he's been running the boot camps for technical writing, for AI and processing, to share all of this knowledge, to make it a lot easier for everybody else who really need to pick this up. So I know some of you have been going to these boot camps, which are really helpful. I've asked him to come today because we've talked a lot about the different things that pretty much everybody has to do in the project. We'll talk about seminars next week, but we've done document preparation, literature reviews, proposals, and probably not completely universal, but a lot of you are going to have to do fairly extensive experimentation. Some of you might be lucky enough to have, large machines or sufficient hardware of your own to use. But for a lot of you, you will be relying on whatever hardware we can scrape up from around the university. And Pascal's really the resident expert on that. So he'll talk you through some of the options that are available, and we might have a question and answer session towards the end to talk about some of the alternatives and what sort of things we can do to make sure that everyone's got access to the computation power that they need. Okay, I'll hand over to Pascal.
Okay, hello everyone. I'm Pascal, and I think today our topic is about how to use Kaya. Kaya is indigenous language here in Western Australia, which is Hello, and they use this one naming the UWS high performance computer. And our structure about the content today will be divided like this. So we will first introduce some basic concepts about the HPC in case you don't really know that before. So it will be just a crash course about the concept behind it. If you want to know more, then you need to go to other materials. And then it's about how the hardware side about the HPC, how they're doing the setup in general, and the software, what's the other software we're using in the HPCs. And if you wanted to get an account with Kaya, how could you do that? And what's our resources available in Kaya? Like how many GPUs? What's the level of the GPU we have there? And then is more intensive ones about how can you use Kaya in your command line and in the IDE. And also recently they have the support about how can you use it through the web interface. So nowadays they have an on-demand web page, and you can open the on-demand web page and open like a virtual machine there and trying to do the interaction there for you to easily to debugging. And in the end, I think probably, I'm not sure whether that's good as a homework or I will do the demonstration, but we have a detailed documentation there. If we have time, we'll probably do a demonstration. If not, you can follow the instructions in the documents to do it. And also there are some tips in the end about, for example, where you store the data, and if you encounter some problem we already encountered before, how could you solve that kind of problems? So it's like this tutorial was being provided help from several of the team members and also the HPC team from the UWA. So yeah, hopefully this will help for you guys all when you're doing the experiment. So first thing is, what is Kaya? As I said, Kaya means hello, actually. If you heard about that, near the airport, they have a very big one. And it's UWS HPC research platform. But the high performance computing is actually a pretty standardized thing. It's everywhere. In Western Australia, we not only have the Kaya, we also have POSI, and we also have some pretty world-class companies, private companies like the DAG was trying to do the similar things. So the HPC is called high performance computing. And the whole concept behind it is using the distributed computer resources to make sure your large workload will be distributed. Basically, in the plain word is, if the work will be done by one person or one computer for 8 days, then we try to divide it to 8 computers and trying to get it done in 1 day. That's basically the concept behind it. And where you will need this for, like there are several different purposes. Typically for us, we want it for the GPU resources, but it's not the whole story. The HPC computer center was being like invented or set up in in the older times is just for the CPU calculations. Like the HPC of the Kaya in UWA, a lot of the biomedical people actually using that very heavily with the CPU, not with the GPU. So like don't think the GPU like HPC equals with HPC. You still have a lot of things about the CPU side, and you probably can like run your computers under the CPU with that. Like they probably have 1 terabyte memory of the system in the POSI. So that's that part. And then for the hardware, the externalized setup from the hardware part of the HPC is something like this diagram. Most of the HPC system in generally follow this instruction across the whole world. So for you, you are the normal user. You are logging into the login node of this HPC, and this will be a Linux machine and a setup. You can log in and do the things. And behind it, it will have a cluster of the computational nodes, which is, you can imagine you have 8 RTX 5090 behind it. And this one will provide the computational resources. And you also have a file server. The file server will share between the computational nodes and the logging nodes, which means if you do any changes on the file server with your code, it will automatically reflected on the computational nodes because it's actually the same disk you are changing. So that will be a very like important concept you need to understand and remember that, because later when we're doing the code editing and the debugging on the Kaya or on other HPCs, you will take advantage of this system design. So you need to change some code on the probably when you're logging on the logging load, and then you run it on the computer load and get it running up. And the file server will be with some shared disks. Like ideally in Western Australia, UWA, we have RDS. I think there is a shared service, like a shared disk file system. Ideally, we can mount it in this instruction here, like to this file server. But I'm not sure like what happened now, but it's like in theory they can do it, but the HPC a bit lack of support. So this part haven't actually been implemented in the UWA. So you will work towards this part, the file server part, and it have the limitations about how large of the files you can store on this machine. So this is a general hardware concept behind it. Then yeah, you basically need to distinguish these 3 concepts. What is login node and what's the capability login node can do, what's a login node cannot do. Like login node doesn't have the GPU. So don't run your like a program on the login node. Otherwise, it will get the whole node be died and nobody else can log in. This happens every time when we have new users onboarding. And then the file server, what is used for, and also the computational load, what they are used for. You need to distinguish these 3 main concepts, and that's all. That's all you need to know, actually. And then it's from the software side, if you want to use HPC, what you will need to know. First is every HPC computer, because it's open source community and it's kind of like HPC team don't probably want to pay that much money to build the whole system. So everything is actually on the Linux. So some of them you probably have the GUI, like what we have now. We have the on demand as a like a graphic user interface for you to do the interaction. But primarily every HPC you can try to log in with with your terminal, like something here. Like if I want to log in, I currently actually already log in the HPC. So like you need to know how to use these kind of things in the terminal. Like this is currently the queue on the Kaya. So that's the first thing you need to know, like how to use this like a share to the interaction. If you don't know that, and if you haven't known that before, we in the UWA, we have one unit called open source tools and scripting, which is CRTS 4407. That unit can help you have more like a deep understanding of this kind of Linux system. If not, then also they have the link for you to kind of to understand in the Linux one. And if not, you can go online. There is a lot of tutorials. You can get yourself familiar with this share and the Linux basic things. And yeah, that's basically the two questions you need to understand. Like, make sure after you have this like self-learning process, you make sure you understand what these two like questions answer is. And some of the frequently used commands when you're trying to use a HPC included SSH, which is a command I just using to do the logging. So like this one here, actually you probably should do it in this way. So SSH and username, and you have a domain to do the logging. That's the first command you need to know. And then when you inside of that server, you need to be able to know how to change your directory. So you need to know which is your directory, and then, oh, yeah, sorry. Yeah, so like this, currently I was, for example, this will get me to the like home directory, but in the Kaya, normally where we started working is under our project directory, which is always starting with something like this. The group is root like a directory of it. And then this PMSing015 is my project number. For you, after your supervisor help you get an account, you will have your own one. And then you will have a directory of yourself and trying to change your directory in. That's the code I actually working on before. And you can see under the same directory, I have my colleagues like there's directory, but because of the permissions of the Linux system setting, you can see I won't be able to get in. You can only get into yours. So that's the second one you need to know. And then is SNARM. SNARM is the key functions. Like the first two, you probably already know that before, but the third one, if you haven't used HPC, you won't be able to know it before. SNARM is for you to submit a job to this HPC system queue. And then you can check the status of your job, whether there is a computer resources already being allocated for your task and running it. And then what's the result of it? Is like it's failed or it's like exists normally. And you can use several commands here trying to manage your like your tasks within the HPC system. We will talk about this more later. And then is a module. Module is the one like in the HPC system. It's not your own computer, which means you want to be able to install anything as you want. So for example, if you want to install like a YouTube on it, no, you won't be able to. Or if you want to install like a CUDA or some support libraries for the CUDA, you also cannot do that. But how you do it, then the HPC team will maintenance like a folder of these like modules and the packages. And if you want to use them, you can load it. So this module is subsequently for this problem. And then you also need to familiar with like what we are doing here as an AI researcher. We normally work with Python, pipe, and Conda. That's all of the command you need to know. So get yourself familiar with these 5 commands, and many is these 2 will be the new one. We will talk about these 2 later. And then is the software part in yeah, that's further explanation about why we need a module system. So you don't have the root access, and it's efficient for everyone trying to install their own package, right? And the different versions, like the GCC compiler, you probably have 10 versions or even more actually. And then you want to use this version, another user wants to use another version. How you resolve this kind of conflict? It's not a virtual system or virtual machine or Docker. So in here, how you solve it is just when you're trying to use it, you use a model to load the versions subsequently required for you into the system. So I think I can show you a example. So currently I was in HPC, right? So you use a module, it will give you some, like the standard Linux system, it will show you something about what's the command you can use. And the normal command that we will use is, I can use the wrong one, model available. So this one will list all the available modules currently actually being installed in the HPC of the Kaya. For example, for us, we will need which one? We will need this one, CUDA. So the CUDA, when you go into the computer loads or when you create a script to run it on the Kaya, you need to do the module load, this CUDA one. So that's an example. And then you can see that's just to give you showing the demo. I use this command and you have the list. Oh, module list. Why my module list just not working? Oh, there is no module actually being loaded. And especially because I actually on a login node. So I actually shouldn't do this because you can see, you can check with this command is like, we don't have a GPU there in the login node. Like when you kind of not sure which node you are in on the Kaya, trying to run this command, because if for us, we definitely need a GPU. If you don't have a GPU on your load, it means you are on the logging node. Don't run the like a heavily computational program there. And yeah, that's a command how to load and unload. That's some examples you can use. You just need to copy the module name from here, and when you're doing the load, you just load this one. It's super easy. And then this is a screenshot to demonstrate what I just demonstrated. So if we will upload these slides or send the slides out, so if you want to know how it works, and you can like follow this one. And then the second one, the command we haven't used before is a snarm. And why these tools are actually exist is because you need to solve the question, how can I interact and run the code on the computer nodes from the logging nodes? Like the snarm is actually the short like a class of the simple Linux utilization for resource management. It's like it's a specific reason for it is doing the job scheduling. So there will be a queue was being managed by the whole system in the background. You don't need to know what happened there. And within that queue, you need to submit your job to that queue. That's basically how this command was used for. And if you want to know like a deeper understanding about how it works, I also give the link for you to explore. And for us, when we're trying to use the snarm, there is also, like the module or other commands, there is frequently used one. That's basically cover all of the commands we normally use in our interactions. The first one is actually snarm allocate. It's trying to obtain a computer load and run it inaccurately. And S batch means S batch submit. So it will submit a batch script to the job like a queue system, and then the system will hand over it when it's like it's your turn. It will take your JavaScript and then run the code follow your like a JavaScript instruction. SQ is the one help you to check like for your task where it is in the queue, and if you want to cancel it, or if you want to check how long more time you need to like waiting, you can use this one to check it and use the scancel to cancel the job. So that's basically cover most of the command we need. So this is a similar things like I give examples about how could you doing the like allocations, this kind of command there. I can trying to do a demonstration here. I'm not sure whether I have the command in my list. Like this one, I was trying to. So as I allocate, then it will be go with the minus p means your queue name. Like for us, this is actually two GPU machine was being get by our group, so I can use this queue name. And then you can see here, I subsequently said I wanted to get the GPU resources with this command specification. Then it says I was pending allocation, and then it is queued and waiting for the resources. And then it says the job has been allocated the resources. And then you can see here, it's a bit different because this one actually install the data SSH. You can see it's green, but here you can see there is nothing here. It actually means you actually like a jump from this login machine into the computational machine. So you can see the differences here is when I'm running this command. you can see it do have the Amadeus A6000 machine was being mounted to this specific machine. So that's the differences. Currently, we are in a logging loss, and then with here you can try to do the command to activate it, a Conda environment. I don't really remember my Conda environment name, but I can try to get one. So you can see I activated my command, and then you can work in similar as what you have done on your local computer, trying to use Python to run your training script or something like that. Jupyter Notebook won't work here. You must do it via the command line in here, like using Python to do something. We will give you some like idea about how you use the Jupyter Notebook later, but this will be the native and the primary ways. How can you use it? And we also have the other command is like how you release another command is how you release these resources. If it's using the sallocate, if you want to release the resources, you just do it like this. It's being released. But if you use the sbatch and trying to submit a job, I think I get something in to do the submit. Probably not. Yeah, I have this. No. Job or jobs none. So you can see here, this is how you submit it. You write a script. It's actually a bash script. The only key difference is on the top. You need to give it a name and where your output will be like put to, and your request about how many nodes you need and what's the partitioning of it, like the GPU partition we need, right? And then like how many memories you want and what's the divide of it. We get a V100 and P100. So here, like I request for the GPU and V100 just one. And if I want to get this wrong, like submit normally as like a HPC user and using it, what I will do is using this one as batch and job submit. You can see it's been submitted. And then we say about the Q command. You can see the Q command will give you all of the people's like jobs in the system, but I only want to see my own one to see what happened there. So I can say SQ, and this is my user account in the POSI. So in the Kaya, so I can just SQ minus U and give my username here. It will showing this is my job ID and this is the positioning I was doing, and this is the name was there. It's not yet being started because it's finished because there definitely is an arrow. Just know it's not yet started. And then when it's like started, you will see it is started. And when it's finished, you won't be able to see your job in the queue again. So you can see the difference is between here and here because my job actually finished. I think they have deleted my virtual environment recently because of an upgrade. We can check the result. I think where is my result to? Yeah, my result is here, so I can go to the result. You can see the result actually was being put here, and in this job script, I was putting there to give it a G. G means like a get my job number, and put it to fill this like a string. So my job number before when I queue it to the system, you see it from here. That's my job number, right? And you can check it with afterwards command to check the job number, and you can see is actually creating this like a running script result. And if you want to check the result, what's actually inside there, I think the fill command. Yeah, what's inside there is basically giving me why it's erroring. It's actually being pulled and doing the running. It's erroring because I tried to allocate it too much memory, and our Kaya don't have that much capability, so it's failed. So I think that's three commands most of the commands we normally use. And for example, if you're trying to do the cancel, it's the same way. You just cancel and put it in your just the job ID we get, and you will cancel your job. And that's the standard way is how we use it. You can practice by your own, and this one actually give a demonstration in the screenshot. And just now, I think in the, sorry? Yeah. Yeah. Yes, that's what I'm going to say. I know you will have the question, so that's what I'm going to discuss. So I think, yeah, as what Peter said, like this one is not that clear for you to read because it's kind of in the terminal, not that good, and you don't really understand what happened there. So I do a summary here. So when you're trying to submit this job, what's inside of this jobs scenario? You can actually name it to anything like with this prefix. But the things inside it, you first declare this is a bash. We will use a bash terminal to do that. And these are the key parts distinguished from a normal bash job script. You need to specify what's the job name, or where your outputs, your running logs will output to. Just now I was putting to is in current directory, the results and the Kaya, and give it like a G to get it to be named specifically in specific format. So I can know like what are the results I'm looking for. And then you need to specify how many loads you want and how long you want it running. Like normally, if it's a owner project, hopefully you don't have too long jobs to running, 4 hours, 8 hours. But if you want to run a code for 1 week or more, you potentially need to specify that for a very long time. We have colleagues actually doing some video generation, need probably 1 week and 1 month to get that done. So you need to specify specifically about how long you need it. Otherwise, your job will be killed before it finished. Then that's a scenario you don't want, right? It's totally waste your time per years. And then you need to specify the partitioning of it. Currently, for us, it's always with GPU. For the biomedical people, they probably wanted the CPU. So that's different things. And you probably want to test it out. They also have a position about the test. We will give you a list of it later in this document to show you like what's different queues capabilities. And this one is like a specific filtering. Like if you want to use the GPU resources, currently in Kaya, the most GPU resources we have is V100 and P100 for the general use. I think for the computer vision people, they have some A100. For us, we have that like A6000. Different people have different ones, but obviously we don't have that much resources. This memory is like the RAM you will need for this machine. If you are heavily need the RAM to do the work, it's not the RAM for the GPU. You just get all of the RAM for the GPU when you're doing it. This is the RAM for you to running a program. If it's RAM heavily, you need to use this one to specify how large is the RAM. It's quite large. You can specify probably 256. So we don't really need to worry about the RAM we need in this Kaya system or the POSI. POSI actually have huge amount of the RAMs. And then within the command, like after this section is actually the normal of the bash script you were using. So you will first need to know the modules you need. For example, the CUDA you were required to run your command. And for some of you probably need a GCC, or some of you need the Conda. You need to model load the Conda. Otherwise, the computer will start with a fresh computer load without any of these packages was being loaded. Then when you're trying to directly run this Python, it won't work. So that's basically, you need to specifically module loading these things, activated your environment. If you use Conda, you will do the Conda activated. And then downwards is your Python script. Or if it's other ways to do the computation, it's your command, how you trigger your training process, something like that. So this is a template about how you do it. And in the documentation, we have a Gitbook page for that. I probably should mention that much earlier, but same as a research bootcamp and AI engineer bootcamp, we actually upload all of these results there. And I think specifically for this one, the Kaya things, all of the commands I just showing you, you can copy it directly from here. So if you don't remember it, don't worry about too much of the taking the load to get a thing. You can get it a copy and trying to practice first from this link. And also all the loads. We'll keep updating that anyway. And then is like after you're submitting your job, as we just discussed before, you will have a job ID. That's the one you use to check the progress, whether it's failed or succeed. What's the progress? Is that too deep in the queue or something like that? And also you can use this command I showed you before to try to check like what happened there. And for the specific jobs log, like if it says it's finished, like what I am doing here, and like from the scenario, I won't be able to know anything. It's just the disappeared of that job. How can I know what actually happened there? That's basically why you need to have that check that output.txt and specify that. So because this one will give me the logs, so I can understand, because this attention area here have the problem to loading all the memory things. I get a problem, and then I need to go back to fix that problem and run it again. That's a normal debugging process. And then if you want to know more about the HPC, you can follow these two links. This one is about the HPC modules, but like UWS Kaya system, do bear in mind, like UWS Kaya system as a HPC is different from the HPC system in the POSI, and also different from the HPC system probably from NVIDIA or the DARC, or like your personal built HPC system. So not all of the modules available here will be available on another machine. You need to use the mode available to check it beforwards. If you do have a specific request for specific packages to be loaded on the Kaya, you basically have two options. One is request the support team to get that being available package for you to load. Otherwise, trying to install from the file system. So for the Linux, every package actually is just a folder of the file. You can try to install it by your own, load the files there. But it won't be fun. I don't recommend you to do that. And I don't think you will encounter that problem. I just mentioned that just in case. And then it's about the SNARM. If you wanted to know about the SNARM's different commands and the different like the dash lines, like what does that mean? Like the positioning, output, load list, all the things, how that was being used for, what each command means. You can check this PDF. It's basically all the commands you were used and the leaders you used will be there. And the one I show you will be the primary one, like frequently used one. I don't think you will use too much other than that. But yeah, as we say, like good JavaScript, the shell script normally need to define the required resources. We tend to be lazy, so if we have one template, like we want to request 256 RAMs, we tend to keep it like that way, but don't do it because the resources actually limited on Kaya. So if you request more resources than you need, it means someone else need to wait for a long time. So just bear that in mind. And set up the environment for your virtual environment for your application. Because we are using the Python, there are different packages and different versions we need to follow. So that's always will be a good practice to set up your own virtual environment for different projects actually, and get your data prepared, upload it to the system. I think I haven't touched the data uploading one, but I will touch on that later. And also then you need to execute the application codes like what we have done in this example code. But what we haven't exampled here is the last step is do the cleanup. Like normally you need to try to move all of your bash files or the large amount of the logs or the things, trying to clean them up normally and trying to download all of the important outputs from the Kaya to your local computer and do a proper backup. Because there is no guarantee from the HPC team says they will keep your data safe. They probably one day they do an upgrade in the system and all your data are gone. That's literally is what I just think what happened for me, because for my Conda, I think I have much more environments should be listed there. I think recently I definitely have like a much longer list of the virtual environment. But recently, because they are doing the upgrade of the storage system, because I think a 2 terabyte or 20 terabyte system is full, so they had to do some like not that graceful upgrade. So bear that in mind. And then so until now we covered from what's a HPC and what's a Kaya, and also the hardware and the software part, all the new knowledge you basically need to know. And then what we will cover is if you want to get access to the HPC, how you do that. So they actually have a standard way to get access to it. You need to use a Kaya HPC service to do it because we are all UWS students, so it will be free for us. But you do need your supervisor because it needed the principal investigator, which is a senior researcher or academic staff. So for me, I definitely cannot be your PI. You need to contact your supervisor and create a project and a request in the system to request for the access to Kaya. And within the project request, they will have something about you need to state what's your project description, how long you will use it, and how many users you have. And potentially, they also ask for the GitHub repo. I'm not sure why they need that. And also the ORCRD for all of the members. I think this is a way to track the usage of the system so they can argue from the high level for more resources to like if they can like grab from this ORCRD to grab how many papers were actually published by this kind of user. They can argue like we are doing good work, so we can argue for more resources. And the RDS, that's actually a weird thing. RDS is kind of a OneDrive service provided for the research data from the university level. So if you want to do the backup and you don't have enough like storage places in your OneDrive or in your local disk, you can request the one here and upload it to your data here to get a backup. But the problem is even if you upload the data to this one, it's a shared disk service. You want to be able to mount it directly to the Kaya. It's doable, but I'm not sure whether they have a long plan to support that. So just bear that in mind. This is the weird part, also very weird. And then this is a link, hopefully it still work. This is a link you can use your supervisor can use to create a request for the Kaya access. So you can share this link with your supervisor if your supervisor don't know how to request access, and give the description over things. And from my understanding recently, because the Kaya team is actually trying to upgrade this kind of storage things, they recently not creating new accounts. So you can submit a request in the system, but you probably won't be able to hear back from them in a very short time frame. But they will support your ticket later. So that's what happened there. And afterwards, when it process your request and give you account into the system, what you will have? You will have a username. Like what I have here is, this is my username. It will definitely different from your student number. That's two different systems. So don't try to use your student ID and doing the login. That won't work. And they will send you a email with user ID and a temporal password and probably other informations. But generally, you will get these two. And then you need to log into the system with this kind of command. I can show you the command. So it's normally the username with a domain. So this domain will be kaya.hpc.uw.edu.au. The first time you're trying to log in, you will be prompted to type your password and type it in, and you will get it in. But after getting in, because it's your first time to log into the system and you hold a temporary password, they will require you to like have a very complex password to be set up, and that's what you need to do. But remember, it's different from FIMI account. It's a specific password for yourself, and make sure you get that right down. Don't forget that one, because if you forget that one, you will then need to have a request to the HPC team in the UWA to reset the password for you. That normally will take some time. So make sure you remember what you said. And another thing to notice is if you are at home, you want to access Kaya, you still can do that. But the problem is if you want to access the Kaya, you must go through with the VPN of the university. Otherwise, you won't be able to access that. It's not public available. So how to use the UniVPN? I have a link here. You can track it from the link. Basically, I think I have a UniVPN. So basically here, you just connect it to it when you're at home, and then you can run this command to SSH login. Otherwise, if you haven't connected to the university unified network, then it will just hang out there. You won't be able to get any response. Also to notice that is, if you I think some of the rooms have that cable. If you want to plug in a cable to your computer and access the internet, you also want to be able to access the Kaya, because that's actually a separate Wi-Fi system from the Unify. So bear that in mind if you encounter issues. Otherwise, you need to call the IT to tell you that. And how to get your first login. If you are the Mac user, you normally have these kind of things. I use iTerminal too. And you can use Mac's iTerminal, or Linux, you have the built-in terminal system. For the Windows, I will personally recommend you to use the Windows subsystem for Linux, because it's native Linux support that will give you better experience. And you probably can install some of the tools in the Windows for you to get some native experience like this one. This part of the instructions, I think we also have a tutorial here somewhere here. So yeah, we also have a tutorial about how could you set up the bash script and the Windows subsystem things. If you don't really know how to do that, you can go there to check it. And we also have a video you can track. It's a bit different from this topic, but the dev environment setup will be similar concepts. And yeah, you will be prompted 3 times during the time. First, you need to enter the temporal password and enter a new chosen password. Make sure you remember that and get that right down. And also confirm the new password again. Then you will get set it. And this is the requirements for the new passwords. Then you will see something like this. I have demonstrated how it looks before. You can see some similar to this one. And there are some advanced ways to use SSH command. For example, just now when I'm trying to do the SSH, this one, you can see I haven't typed anything. It just goes in. It's because I have copied my public key to that machine. So it will know this is a secure tunnel. So I don't need to type the password. If you want to do the same way, you just run this command. And it will pop up you to put your password in, and you put the password in, and it's done. Next time when you're doing this SSH, you don't really need to type the password again. This potentially can reduce the risk of you forgetting your password. And another thing, I'm not sure whether you noticed that I have trying to log in also by this way, using the SSH Kaya. Oh, I already inside one. So if I from the home machine, I doing the SSH Kaya and it works. This is actually an alliance for the settings above. So you basically just need to in your home directory .sh folder, and there is a configure file. If you don't have that, create one, and then you can put these settings here. After you're doing this setup, then next time you can just doing this SSH Kaya, and it should work. Another simple way. And if you want to upload your data to the Kaya, how could you do that? There are actually 2 ways. As like a hacker, or you feel like you like the coding way better, you can just use this way to do the uploading. So that's the SCP way to do the uploading. You just need to, for example, I have to do some of this. For example, this one. SCP -R means recursively, and I want to get all of the files from this directory uploaded to the Kaya, because I set up a Kaya to be the home machine, that machine before was, and it will be uploaded to this machine's this directory, and you just trying to type this command in and upload it. That's how you do it from the SCP. And if you don't like the SCP way and you wanted to have more user-friendly GUI to do that, you can also do that with download this. I'm not sure how to pronounce this name, but you can put your host like a kaya.uw.edu. And your password, your name here, and then it will go to connect to the machine. I don't really remember my password, so I won't be able to demonstrate it for you. But you can basically click, after you click after you click connect, it will give you left side your local machines, all the files. Right side is all the files in that Kaya. You can click the left side one, it will upload to the right side. If you click the right side one, it will download to the left side. So you see you have this kind of GUI interface for you to track what you have done. You don't need to type the commands. And you can, here, this part specifically is the places you can track the progress of the downloading. So that's about the uploading. I think I only have these two ways to do the uploading recommending for you. I personally recommend you use this way. It's more reliable actually. And that's the things I was mentioning before. The IRDS is a weird service provider university, not really supported by the UW. If you encounter that next time, don't feel too weird because I will tell you that. And then is the capability. So what's the capability? Like what's the resources is available in the Kaya? We have set two different types of the resources we need. One is a CPU, one is a GPU. So for the GPU, we have 5 nodes, five nodes, which each node have 2 V100, and the GPU memory is 32 gigabyte. That's GPU memory. And we also have another 10 nodes, each node with 4 P100, and the GPU memory for each one is 16. And it's because it's a machine, a GPU machine, is similar as your gaming machine. It will not just need the GPU, it also needed the CPU chips and also the RAM, the memory RAM. So that's the RAM behind it. That's Intel's like RAMs, 36 cores in total. That's many RAMs you can access with the GPU side. And if you want to get the CPU, there are 15 million CPUs and with that much RAM. And there are 5 large nodes and with that RAM. We normally handle it here. Okay, and then the storage, when I write this one down, in total, the storage in the Kaya is 120 terabytes. I think they're starting to trying to upgrade it. And there are things to notice here is there are several types of the folders here in Kaya specifically. So first one is the one I tell you, like the group folder. That's a folder where you should store most of your files and the experiment files in, because that's inside like a standalone like a disk, which kind of support all of these things, computation things with SSD. There is another folder called Scratch, which is it's different from this like a 120 20 terabytes files. Limited is 30 terabytes. This is kind of a temporary storage place. Is the Kaya supporting him will do regular cleaning. And so if you store something here, it definitely will be cleaned afterwards if it's full. There is no guarantee you will get that. And also there is another temporary files, which is a Linux system default, like a temporary storage places. Sometimes when you reboot the machine, you will get rid of that. The home one will be the default one where you log into. So why I need to mention that is because when you're doing this command and you log into the system, currently you're actually in your home directory. That shouldn't be the places you do your main work. You need to change your directory to your project directory under your name, and then do your work. So which will be able to get you to use this 120 terabyte and more resources later. And it will keep being highlighted by the HPC team from the UW. So I'm trying to help them to reduce the workload. And yeah, that's just another highlight about what I just saying. And there are several queues you can try. So which is called partitions. Just now what I put there is GPU. And you can put it as a long. If it's long, you can use it like without exit for 1 week. If it's work, that's medium CPU part of the resources you're trying to allocate it. Then it's also 3 days. If you're trying to do the test, then it's 10 minutes. You just testing your script. It can be started properly. That's all. And on demand is a new partitions was being spin up for the GUI I will mention later, but this is only 4 hours, and it will. When I write this down, it doesn't have the GPU support, but currently they do have the GPU support now. So I think for you guys, you normally will use these two, the GPU and the long. And when you use like an interface, the GUI interface, you will like intuitively being allocated to this queue. And if you wanted to know how long for me to like in the queue and what's the resources and allocations like usage of the HPC, you have 2 links here you can access. And this part are the GPU's resources. Currently, we can see it's empty there actually. Nobody using that. If someone using that, all of the GPU resources will go 100% or 90%. For now, it's not using it. But the CPU, you can see is actually, there is a lot of people currently using that. And you can see how many running tasks, how many pending tasks. That's where you can use. This one is a report. I think they're trying to report it for the high level, like different scores using that how much. For us, we are the PMC group. You can see we actually haven't using that much. Most of the usage are being done by informatics score people. So if you need some more jobs done, just get the Kaya busy. And then is CLI instructions. I actually already demonstrated that when I was trying to do this like a tutorial. So I was trying to get it quick in this part. So normally when you're trying to run a Python project on the Kaya, that's a procedure you need to follow. First logging it and then get your code or the end of the data being transferred to the Kaya, set up the virtual environment, use a Conda or pipe. Sometimes Coda will work. Sometimes if it's not working, you can use the traditional ways like the Python virtual environment creation to get that done. And you need to allocate a computational loads and load the required modules and on the computational loads, not the logging loads. Remember that. And then execute your programs on the computer nodes and retrieve your result back from the Kaya to your local machine, because it's potentially will be lost here. So this is an example about how could you do that, and this is an example command how could you allocate a computer loads interactively. That's an example about like I have shown you before, and this is a successful like a process I have done actually before. So you can see the screenshot. If it's success and it's interactively, you will be able to just directly see the logs from the terminal. Same thing as what it will be logged in the login text. And this part is, but using the CLI way have a like a bigger problem is if you're trying to get it running in, for example, this way, you're running a Python script. I can get allocation to a loads. If you're trying to run a command on the compilation loads like something like this, then it will automatically time out, which will make you like kick you off from the system later if you are interactive. And in this way, if you kick you off, your program will be killed, because that's how Linux was designed. You have like an exit terminal there. So you need to run the jobs and submit it to the queue and use the queue to run it. So your program will run in the background. That's basically why, another reason why you should use the job snarm rather than the CLI. And this is another example about what snarm will looks like. And you can see this actually is this one here specifically is when your program is actually running, what it will be looks like. This one is actually is running already nearly a day. So next. And I know like that's actually come to the point is if we keep doing this programming things in the terminal, you will feel pretty exhausted and it's not really efficient enough because you will feel, I need to change the code from my local. I upload it to the logging loads and then I go to the computer loads and run a command to get my program running. That's very annoying and not sustainable. Can we get it more efficient in the IDE way? Yes, we can. And because of the system diagram we mentioned before, the logging nodes and the computation nodes will share the disks, right? We take advantage of that so we can edit the code from the logging nodes using the IDE and then trying to run it from the computation nodes. So how it works is if you have the VS Code, you can try to install the remote SSH. And then because you have set up normally you should already set up the one I have mentioned before, like in the .ssh configure file, you will be able to see that from the list. And then currently I was in that server now. And then I need to go into my, let me just open it. So you can see I use VS Code and I trying to SSH, use a remote SSH in the VS Code, get access to that login node on the Kaya. And in this way, I will be able to check over the files on that machine. So that's basically the code I'm working on. For example, this one, you have the models. If you want to change the model, you change the model, right? You put the code there, like what you have done in your local. And then how could you get it running, get your program running? It will automatically get your login into a logging nodes. But that doesn't mean you can run your program there because it doesn't have the GPU. So what you will do is you open this terminal and it will pop you up in the logging nodes. Then you can use, where is my allocation code? Like this allocation code. I may need to delete from here. Yeah, I can get access to. Yeah, sometimes it will take time. But when it's give you the allocation of the resources, you are being able to, so it's giving me the resources now. So I'm in that computer load, I can have the access to the GPU. And I need to change, it's already in current directory I was working on. Then you can run your command. After you change this specific program files, Python file, you can in the terminal, ask it to run the script for you. For example, if I want to run it in the I don't have that file anyway. That's my code. And oh, okay. I use another way to active the virtual environment. And then I can try to run where is my job scenario? So in this way, you can see, I can see over the commands here, but let's try to run one, a short one. You can see currently, if you change any code here, like in these models, under this project, and then you want to try it, then you will be able to access it. But here you can see it's telling me I have an error here because of this reason. Then you can go back to check the code again and like optimize it, get it up and running. So that's a standard process if you want to do the IDE ways to do the program. This definitely will increase your efficiency because you change the code here, and then in your command, you just keep running the same debug things. And if you want to set up the debug tools, if you are the guru somewhere, you can use a VS Code to set up the debug tools. And next time you want to retry, just click a button, it will automatically restart the script for you. So that will save you a lot of time. So that's one way with VS Code remote. And another way we can use is this JetBrains gateway. This is actually a similar service as a VS Code. It's just provided by the JetBrains. It's also trying to do the remote access. I also set that up because in that way you can use a PyCharm automatically in your terminal or in your interface. So you can use a PyCharm, for example, this one here. If I click it, you can open the PyCharm on your own computer and use all the functions in the PyCharm, and then doing the coding and run in the like a command line to say I want to allocate the resources and run on the GPU machine. So that's just the two different ways how can you do the interactions with Kaya inside of the IDE. VS Code will definitely meet most of your requirements, and JetBrains probably depends on your personal like preference. So this will give your illustration how to use that as what I have just demoed. You can follow the instruction here to do it. And that's a workflow. If you don't remember what I just saying, you come back here and check what's the workflow you should follow. And JetBrains Gateway is a similar thing, but it's need a license because we are students. You can use JetBrains free license to do it. It will get you have a good habit to writing the code actually. So I personally quite recommend it to you to do that. And this is the interface for the JetBrains, and you can see it's being opened with this kind of interface, and you can use a similar ways to do the interaction. So that's the second way we can use the Kaya. And potentially you will ask, do I have the third way? Like, because probably some of you guys only use the Jupyter Notebook before. Can I use the Jupyter Notebook directly in my browser? Yes, you can. So we have two options previously, but currently we only have one because the other one is a bit hacky, and Kaya team don't allow us to do that. And they do provide the support to get the on-demand way working. So what's the on-demand? This is the link of the on-demand. Oh, damn it. Do I remember my password? Oh, I don't remember my password. That's bad. Oh, I don't remember my password. I'm not sure whether I can demonstrate it to you, but I do have a screenshot anyway. So this is the link you can go in, and then you can log in with your username and your write down password. And after you log in, you will see something like this in the browser. So basically means you can do it anywhere on the world, just have a browser. That's it. And then if you wanted to get access to the on-demand by the to the Kaya on the on-demand, you can click. I think it's interactive app. This one here. I should do a like more better demonstration, but you click this one, it will take you through to this interface, and this part here will be automatically filled because they know your account and the position definitely is on demand. Then you specify how long you want. It's similar as a JavaScript we defined before, and how many calls, and then you click launch. It's similar as you launch an instance on the AWS. So you click launch, it will have, yeah, for now, if you want to use a GPU, they have the Kaya on GPU on demand. And then you click the launch here. You will be able to track it in this interface. It will say queued. And if you not just queued, it will be allocated, then you will see something like this. And after you get this one, you can click the launch. So this button here, launch Kaya on demand. Then you will magically see something like this. If you take the cybersecurity unit, this interface will definitely be very familiar with you because that's just a virtual box. So this will pop up in your browser, and it's interactive. You can click this like the terminal and do the command we just described it before in the terminal as you want. And if you just want to spin up a Jupyter Notebook and open the browser, and doing the interaction. You just open the terminal and run the drop your logbook command in the terminal, and then open your browser and go to the local host 8080. And that's it. You can use it like what you have done in your local. So do I have a drop your log? I don't have a drop your logbook like a demo, but I think my demonstration code do have the instructions take you to there, so you can follow it from there. But this on-demand way will be the simplest way for you to get started and get familiar with and do the junior notebook in the browser. But personally, I would recommend you use the IDE way. That's actually more stabilized and more straightforward. So that's all three different ways you can do the debugging and the development with Kaya or other HPC system. That's all a similar idea. And then later is a demo or practice. I'm not sure whether should I do the practice. Probably not. Yeah, so the demo project link is here. So we have all of the instructions about how can you create, like how could you load the module of the Conda? How could you create a Conda environment with all the Conda environment files actually being put into a specific folder? In this way, you don't take the temporal folders on the HPC machine. So it will saved on your own project folder because of this prefix command. And then you can specify what's the version of the Python you want to use. And you can try to clone this code. That's one of the research code I was trying to learning from. But if you don't, it's probably not your area, but you can use this one to learn how to use a Kaya. You just clone this code, and then you get access to one of the V100. It will give you the access. You activated this virtual environment, and then you can try to run this command. It will give you this. If you run it in the interactive like a share, it will give you something like this. And then if you go to the monitor, you can figure out this one will go to 100. This one actually is when I run it, it's going red. So that's basically how you do it in the interactive ways, practice it. And then you want to run it in the script way. This is the example script we provided. So you can copy it there and trying to get it started. So you can see on the top of it, it will say GPU. The work time is, I haven't, the work time is 3 days actually. And then you give it a name, you give the memory. Don't take that much. I just, I don't know that at that time. And then you can set up your script. These are some variables you can easily access. Like the my group is actually will take you to your group. Like for me, it keep taking me to the group. For example, for me is taking to this my group. It will be already built into the system, so you can use this ways to as a shortcut. And this one where you can see it's trying to list all of the codes you have actually to make sure you in your running process is actually running it there. And then it's we're running that learning command and gathering the results and say it's done, right? So this is using the batch ways to run your script. That's a demo there. It's pretty straightforward. You just follow the instruction and you should get it working. There are several tips. That's the one I was just highlighted, like use a prefix ways, because this one will get your virtual environment saved in your folder. If it's very large, it's still fine. If you're using the a default ways, it will be stored to Kaya's temporal storage. That's 30 gigabytes. You potentially will lose that sometime, as what I have happened to me. And our solution is use a Vim. Vim will definitely with the folder being created under your current folder if you do it this way. And the Hugging Face, this is another trick. If you guys using a Hugging Face later, Hugging Face normally need to download a lot of models. And the default places the Hugging Face will download model to is your home directory and the .h file and this one. This is hit the same problem in the Kaya because Kaya don't really want us to store anything in the home directory. We want to store it in our project directory. So you need to add this command to your bash profile. So next time when you log in, it will automatically reset your Hugging Face home directory to your project directory. In this way, you won't be able to hit with a problem later. It's like we're trying to download a Hugging Face model, and your code for the disk exists, so you want to be able to download that. That's normally the problem will happen if you don't do it this way. And I think that's all for all the tips and things. And the Kaya is like we use a lot for like Kaya to do our research, and you definitely will do more. But Kaya resource is definitely limited. Even nobody are using it now, but we definitely need more later. So yeah, encourage you to maybe put some letters to the university asking for more GPUs. And the link is also being included. You can check it from there. And yeah, that's it. Thank you. Any questions? Yeah. Yeah, yeah, you can.
Yeah.
Yeah.
Send me the latest slide.
Yeah. No. You same thing as what I show you there is you needed to use the model list. It's not actually being automatically installed. Why when I goes in, it's automatically give me the conda is because when I set up the conda, my bash profile already have that command in to do the loading thing. Yeah. So if you go into the system, you're trying to use a conda, you find that the command is not loaded, trying to use a module, find out that the conda, where is conda? Yeah, find that conda is like a module trying to load it. Yeah. Yeah, that's actually using the way. So we mentioned two ways you can use a Kaya. One way is interactively. The interactively using the Kaya is actually meter the policy, and every HPC system provided that capability. The interactive way they actually give you the capability to do the debugging. So they allow you to do that anyway. And how they like make sure like normally what happens is someone get access to resources and they haven't done anything, right? And if they keep holding that, then the resources will go. So that's basically why you have that work time. So where is my slides? For the interactive, so you have this kind of maximum work time. If you allocated it like interactively, it's normally it should be 4 hours. So if you haven't done anything, or even you done a lot of things after 4 hours, it will kick you out. Yeah. So in this way, they kind of make sure you kind of get out of the queue. So make sure you don't really use it in the wrong way. Yeah. Yeah. We, why what? Why? Yeah. Yeah, yeah. But here in that places, you want to be able to set up your work time to probably 1 week or 3 days. You only can do it through this like command line and JavaScript. In there, that's actually been hard coded by them. Yes. So that's in the queue to allocate a resources. And then when it's allocated resources, you will get a, so this is a, no. So you basically, it's another way to access a Kaya interactively. So you use the interactive in this, like the broader way. Okay, another question?
So how many people here are anticipating needing G? And how many have got a solution that they're happy with? Okay, a few. So those of you who don't, it's probably good to talk to your supervisors early, see if you can at least get your name down to get accounts. I mean, like Pascal said, there's a bit of pressure on Kaya at the moment, but I think the more that we show it's a useful resource and the more we show at the university that it's worth investing in, the more likely they are to invest in.
Yep.
But failing that, there are other options. Talk to your supervisors early. We do have some budget for
Colab.
compute
Yeah.
just from AWS or wherever, or Google Colab or those sort of things. But you do have to be really proactive to make sure that you're going to get the resources when you need them.
Oh, Kaggle also gives you 30 hours a week of GPU usage. Yeah, they give you can use the interactive machine that has 15 cores.
That's good to know. Yeah, and it makes a lot of sense to use those resources, at least to kind of build up your pipeline. And chances are second semester by about week 4, you might decide that you suddenly need a lot of compute all at once. Then it's good if you've got some budget left over and a pipeline that, you know, is really well established that you'll be able to run. Okay, any other questions?
Any question online?
Okay, and everybody's happy with where their project's at and they know what they've got to do and yep. Okay, excellent. Well, we'll leave it there for the day. Let me know if you got any questions and I'll see you all next week.